Okay, so we can use rational equations to help solve word problems as well. So these are some, I'm going to show you an example of a work problem and a distance, rate, time problem. These are some of the more common types of real world scenarios that you might see that would use rational equations. So the first problem, James can paint a room in 5 hours and Anne can paint the same room in 4 hours. We want to know how long it would take them if they were working together. So we're going to put these in terms of how much of the job they can get done in 1 hour. So James finishes the whole thing in 5 hours, so that means he gets 1/5 of it done in an hour. So we're going to express James as 1/5 in an hour. And Anne can do 1/4 of the job in an hour. We don't know how much it takes both of them together, so we're going to call that T. But we know that they can get 1 out of T done in 1 hour. That's the amount they could get done in 1 hour. So together, so we're basically going to take the sum of these, and this is the total together. So we're going to write this as 1/5 plus 1/4 equals 1/T. So the amount he can get done in an hour plus the amount she can get done in an hour is the amount they can get done together in an hour. So we just basically put the work problems in terms of how much of the job they can get done in that hour. All right, and then we need to find the LCM, or the least common denominator, least common multiple of 5, 4, and T, which would be 20T. 20 is the smallest number that divides 5 and 4, and then we need that T factor as well. So I'm going to multiply both sides by 20T. Now, remember, that's how the goal here when we're multiplying by the LCM on both sides is to eliminate the fractions altogether so that we don't have to deal with them. So I'm going to go ahead and multiply this through, and you will see that we will get rid of all of these fractions. Be careful here, you do need to multiply that by both of those terms on that left side. So we're going to multiply through, remember, multiply numerator and multiply denominator straight across. So 20T times 1 is 20T, over 1 times 5 is 5, and then 20T times 1 is 20T, over 1 times 4 is 4. And then over here, 20T times 1 is 20T, and T times 1 is T. And then I still have fractions, but they will reduce, and that's what multiplying by the LCM does for us. So 20T divided by 4, but divided by 5 is 4T. 20T divided by 4 is 5T, and over here the T's cancel, and I'm left with 20. Adding these together, since they are like terms, I will get 9T equals 20. And that's a nice and easy linear equation. All I need to do now is divide by 9. And I will get T equals 20/9, or if you write that as a decimal, it will be approximately 2.2. So it will take them approximately 2.2 hours working together. Okay, so looking at a distance, rate, time problem, this is a very common problem. The formula here is distance equals rate times time, D equals RT. So in this scenario, I have train A traveled 100 miles in the same amount of time it took train B to travel 80 miles. The rate of train B was 10 miles slower than 10 miles per hour slower than train A, and we want to find the rate of both trains. So what I'm going to do is I'm actually going to set up a table. Tables make this a lot easier to kind of organize the information, and since we know this formula, we're going to set it up as D equals R times T, and I'm just going to fill in the table with the information that I know, and then that equation is going to help me pull that information from the table. So the distance for train A was 100. The distance for train B, forgot my B, is 80. And then the rate, I don't know the rate, but I do know that train B was 10 miles per hour slower than train A. So I'm going to call train A, that's the one I don't know anything about, I'm just going to call it R. And I know that this is 10 miles per hour slower than that. So I can write it in terms of that other one. And then T, the time, I don't know the time, but I do know that it's the same time for both. So I'm just going to write that as T and T. And if they were different times, then I could not do that. I'd have to have like T1 and T2. But because they are the same time, I can use the same variable. And I know that because of the problem. All right, so what I'm going to do is I'm going to write the equations. 100 equals rate times time. So I'm just pulling that D equals RT, and then 80 equals R minus 10 times T. So distance equals rate times time. Now I have two equations and two variables, and I need to solve those two variables. This is a system of linear equations. So what I'm going to do is I'm going to solve this for T so that I can plug into this formula and have an equation in just one variable. If I solve this equation for T, I'm going to just rewrite this down here. I need to get T by itself. I'm going to divide by R in order to do that. The R's will cancel and I'll have T equals 100 divided by R. And then I can take this and plug it in for that T. So that's what I'm going to do. I'm going to substitute it. So R minus 10 times 100 over R. Okay, so remember that this is understood to be over 1, so I can go ahead and multiply those numerators. It'll be R minus 10 times 100 over R. And then what I need to do is then distribute this 100. So I'm going to have 80 equals 100 R minus 1000 all over R. And then to solve a rational equation, we need to multiply both sides by the LCM. The LCM here is R. That's the only thing we even have in that denominator. So I'm going to multiply both sides by R. And then I'm going to bring this up here to finish it. So I'll have 80R equals 100R minus 1000. And then solving this, I need to subtract 100R. So this is a longer problem, but this part shouldn't be too bad. It's just some algebra solving a linear equation. So this will be negative 20R equals negative 1000. Don't forget that negative when it comes down, those cancel. And then dividing by negative 20 to continue solving. I will get R equals 50. So that is my answer for R. R was the rate for train A. So train A was going 50 miles per hour, and train B was going 10 miles per hour less than that, or slower than that, so that is 40 miles per hour. So that is the answer to our question. So it is a little bit longer, but I think, if you try to do this without the table, certainly it's possible, but I think the table just kind of helps you keep organized as to what you know and what are the unknowns, and relating one unknown to the other, and so forth. So, all right, so that's it for word problems.